So let's continue to do what we were doing before. Right now we have you have your top level VHDL from Vivado underscore hardware underscore portaform. So what is this? What is this file here that is presented to us? This is the system.hdf file here, and in here you have an address map for your processors. You have two cortex, so you have address for every single one of the peripherals that you use in here, and you have the IP blocks present on the design as well, all listed here. So once this is done, what we're going to do is file. We're going to create a board support package. We're going to call it standalone because we won't be doing anything actually really big. So you can call this standalone underscore board support package underscore 0. That's okay. Just finish this here. As you see, you have a new folder here, and the system.mss file just pop up. And here we have the target information. Yeah, that's okay. Just hit OK here. So it's compiling to run the folder targets. That's your project HDF, and that's your target processor. It's a Cortex 0. Here you have the operating system and the peripheral drives available. So once this is done, we are now eligible to create an application project. A different way to do so, it's actually you can create a board support package in the same time. But I'm gonna use the first one that I create here, and I'll call this one switch underscore logic. Just get the hello world template because you had some part of the code that you won't be needing to change every time you're trying to do something. So in here you have a new folder now. Just go open this, go for sources, and hello world.c. That's the program that your board will be targeting. And something good to do actually, it's to run this and make sure that all your connections are okay. So go here to terminal, go for settings. In here you see that's a connection type to be made. I'm using a USB, so it will be a serial connection. He identified the port as COM5. For Zybo board I think this is correct, and for Z board it should be COM3. In here we want to update the baud rate to 1152.00. So you hit OK here. You see that there's a connection made to your terminal, and right now you're gonna right click, switch logic here, you're gonna run as, and you're gonna launch on hardware GDB, sorry. So as you can see, there's a progress bar here on the bottom. I like to pop up this up, see what is happening and the progress. Say the FPGA configuration is not done to the target, but well, that's okay. You just want to print a hello world in the terminal. You don't need to do that now. So once this is done, you see that the console actually goes for home tab here. But if you click terminal, you see that there's a hello world message here. It means our connections are all okay. So right now what we want to do to get our LEDs to light whatever the switches tell them to light is actually we're gonna modify this code a little bit. I won't be typing all of this, but I'm just gonna add the entire code, and then I'm gonna explain line by line what's going on. Yeah, don't worry about the warnings right now, just save this. The reason that we have those errors is actually I finished to copy the code here, so make sure you get everything. Go back to SDK. So right now when you save your file, you see all those errors must be gone. Yeah. So what we're gonna do actually, we're gonna add some includes that we don't have before. So by the end you should have platform, XCGPIO, XCGPIOPS, and X parameters. And also you want to include the studio to run a simple C code. So in your main you're going to declare a config structure here, which will receive the initial structure. So if you just left your mouse pointer on the top, you see that pops some information for you. This type def contains configuration information for a device, which is a base device ID and a base address. That's pretty much what this structure held. So you can do the same for this. And you see there's a base address, if the device is initialized ready or not. and if there's interrupts to support in hardware, and 2 channels to support any of those. So declare some of the variables that we'll use later: status, x status, unsigned integer, which will be the dip values and the LED values. There's also a switch count and a task mask we'll be using to power on the LEDs to do the logic. So in here, there's actually where our program actually begins. So you're gonna print a message saying, hey, those are application results. And here you have GPIO config. You want this struct here on the top, this pointer, to receive the whatever comes back from this function, but you don't know what this function does. So if you hold Control and click on this function name, you open up the library that contains it, and you see that he used the device ID to configure some of the stuff here. So he will be giving the lookup configuration here, which is you're going to initialize your configuration for your GPIO. Then in here, after this is done, is saying, hey, those addresses are actually GPIOs, and this is a GPIO connected to your processing system. You're gonna get some status using the configuration initialize. So in here, what he does is he checks and he puts the values on all of those information that you used to have here on your structure. If those status are successful, and you're gonna print a message to say, hey, your PS MIO initializer was successful and your PL GPIO initialization was success. So in here, we don't need those comments here. We want to set the directions of the bits and the GPIO. So in channel 1 you have inputs because you're popping 4 ones in there. So all the 4 bits here will be indicated as inputs, which will be our 4 switches. The GPIO channel 2 is connected to the LEDs. Those will be outputs, so you just have to add zeros to it. And by the end, you have a GPIO PS. You're gonna put as an input. It's an LED, but you're actually gonna put information on it. So this is why this value is 1. So right now we start a loop forever. You see while 1 here, and where it closes. He's never gonna go out of this loop. This is why we're doing this. And you get the dip value will be your XGPIO discrete read of the GPIO that you declare to receive the values, and the channel, which is channel 1. If you don't know what this does, again, hold Control, click, you see what it does. This is an unsigned value for a channel. There's your pointer for a GPIO, and he will say whatever. He will be executing those codes here. So once this is okay, once this is done, your variable dip value actually is holding some value, and then we're going to put this value in your LED value, because we want the LEDs to light whatever the switches have. If you want to invert the values, all you have to do is put a NOT in here. I'm not going to do that now, but again, we're going to print the screens just to help. We're going to print this using the UART cable to help us to debug the code in case we got some errors, and then we're going to write back the value to the GPIO. So you're going to have a GPIO discrete write in your channel 2 the LED value. Once this is done, we zero this variable here called switch count, and then you got a simple for loop just to test if you have if 2 out of the 4 switches are affected by that. Don't need those comments here, those are for earlier debugs. If your switch count is greater than 2, you're gonna use your XGPIO PS write pin. Pin 7 indicates a LED connected to the XE to the PS, and in here we have the other condition, which is you don't have enough switches, so power off that LED. So this is the code that we'll be using. I'm gonna save now. So what we're gonna do now is we're gonna program our FPGA here, because we'll be using the programmable logic now. And once this is done, we're gonna launch the same application again. So once this is done, you see the terminal here. He's printing some values. I can change the switches here, and you see the value changes as well. I'll make a video with the results to be updated on YouTube as well. So you should trigger all of them. You see F, 7, 3, 2, 1, and this is our application.